Ayubovan, everyone. Thank you for joining us today on another session of Tech Biz Talk, a knowledge series done by HCL Technologies. We hope that you and your families are safe and in good health. I am Suraj Bharadwaj, and I would be your host for today. Before we begin the talk, I would like to share some key instructions with you all. During today's talk, all attendees will be in a listen only mode. And for the best experience, please select the full screen view on your screens. There will be a Q&A session at the end of the talk. Today, we shall be talking about a very interesting field in the IT industry called cloud native services. All of us use it daily when we use Facebook, Netflix, Uber, Amazon, and plenty of other applications. But before we move into that, it gives me great pride in telling you that we in Sri Lanka are about to cross more than 2,000 ideapreneurs. And also that we inaugurated our new facility in November last year in Colombo in Cinnamon Life. The interesting thing about the office is that each floor is thematically dedicated to a city in Sri Lanka. May we have the video, please? Indeed, a beautiful office in beautiful Sri Lanka. And what a milestone to achieve despite the global pandemic. Moving on to our main topic of the day, cloud native services. Did you know in 2021, the global cloud application market had a value of more than 133 billion US dollars, and it is expected to reach 168 billion by 2025 and to reach 1,554 billion by 2030. Demand for cloud native technology will only increase significantly as companies modernize their systems. And this has only been reinforced by the aftermath of the pandemic and the large cyclical movements that are shaking the world today. Cloud native services are here to stay. We have with us today our keynote speaker, Mr. Senthil Kumar Alagarsamy. Mr. Senthil is a senior solutions architect with HCL Technologies and has over 2 decades of experience in the IT sector and is currently based out of Bengaluru. Having done his master's in computer applications, he joined HCL in 2008 as a technical lead, and since then has been a part of multiple delivery engagements, primarily in the financial services domain. He has a vast experience providing customer-focused solutions in niche areas like DevSecOps, cloud native, site reliability engineering, databases, and more. He's passionate about learning emerging skilled areas and likes to mentor junior associates. I would now like to hand over to Mr. Senthil. Senthil, over to you.
Thanks, Suraj, for the wonderful introduction. Hello, all. This is Senthil. So, probably I would start the session straight away, probably without taking much time. So, Kelu, can we move on to next slide, please? So, as Suraj introduced, so this is a brief introduction about myself, right? So, I have been part of HCL for the last 14 years and predominantly working on DevSecOps, site reliability engineering practices, as some of you must be aware of these terminologies. DevOps, which includes now security. So that's why it is called DevSecOps, site reliability engineering, probably, which is catching up a lot today in the dynamic market we have today. Cloud native solutions. So this is the topic for the day. So where I'm going to talk about what is cloud computing all about. We would look at the deployment models. We would look at the platform services, and then probably move on to what is this cloud native all about. We would look at a brief into what are these cloud native design architecture. We would look into the cloud native tools and technologies, and then probably would move on to a bit of the 12-factor app, which is a must for the design principles to be adopted for a cloud native solution, right? Next one. As Suraj lightly mentioned, right? So cloud, if you look at the topic itself, it is at the center stage of digital transformation, right? So if you look at probably at after this COVID pandemic, right? So cloud is acting as an enabler. Imagine, probably I was reading somewhere Netflix. So after COVID pandemic, right? So they were able to double the business to almost 150 percentage, right? So they were able to grow at the pace of 150 percentage points. So that shows the kind of demand, um, probably digital transformations creating. So today, if you look at any store, any physical store, probably they have their own online services, right? You take e-commerce, you talk about transport, travel, or uh, entertainment, leisure, whatever it is, right? Banking, financials, insurance, everything is probably at the touch of your smartphone, right? So this is where probably digital transformation probably is taking place across, right? And probably it is allowing organizations to probably create highly innovative digital products and service offerings, and especially technology, especially cloud, right? It has become a vital enabler for business continuity practices in a rapidly evolving market dynamics, right? So for all this, right? So today when we talk about cloud native, right? So you must be wondering, what is this cloud native all about, right? This cloud, right? So cloud is something which has become a core actually, right? It has become a core. Earlier we used to talk about on-prem, right? On-prem services, on-prem data centers. Today we are looking at data centers being managed on the cloud, the private data centers we are talking about, right? So if you look at the kind of adoption we are seeing in cloud, right? So from all these business enterprises, almost 90% of the organizations or enterprises have adopted cloud, right? And 37% of those enterprises, they have fully achieved or they have leveraged all the cloud services. See, moving to cloud is one thing, right? But leveraging the services of cloud, right? For example, if I talk about AWS or if I talk about Azure or GCP, they have so many services. They have probably more than 250 plus services being offered by each of these cloud service providers. But not many enterprises probably they leverage all these, right? So that is where let's understand what cloud is all about for those who are very new to cloud, and let's say why cloud is at the center stage of digital transformation and what is cloud native all about. Yep. Next please. Okay, so before we get on to the different areas in cloud, let's try to briefly understand what is this cloud computing all about, right? Why we are talking about cloud. So I would not take much time in terms of introducing all these, but I would probably talk about the definition, which is very vital. When we talk about cloud computing, what is this actually? This is on-demand availability of computer system resources, especially when we talk about the data storage, the compute power, right? Without direct active management by the user, right? So today you have so many services which are self-managed. You have available them on demand, right? You have broad network access, you have rapid elasticity, you have measured services, right? So these are some predominant characteristics of cloud actually, right? Large clouds often have functions distributed over multiple locations or zones or data centers or availability zones, which we talk about, each location being a data center, right? If you look at probably the way cloud is designed, so I would talk about in detail when we talk about the platform services. So a brief about who are these cloud service providers, the top three providers, especially when we are looking at, right? So Amazon leads this 180 billion cloud market today, right? If you look at the kind of market share AWS enjoys, the Amazon Web Services enjoy, it's almost 33%. And probably they are the leading CSP or the cloud service provider, closely followed by Microsoft Azure. Probably Microsoft Azure and Google Compute Platform, they were probably late entrant in cloud, right? AWS was always a pioneer. In fact, it dates back as early as probably 1994 when Netflix was the first customer for AWS. And probably from then on, there is no looking back in terms of the growth AWS has enjoyed. And probably they are the premier cloud service provider. Many organizations probably have onboarded onto AWS cloud, right? And if you look at Azure being a late entrant, predominantly being known as a Microsoft shop or a .NET shop, today probably it is open to probably providing any kind of services, be it on open source, be it on COTS or any other platform, SaaS platform. They have all the services what we need. Those today they seamlessly support Linux platforms, right? Earlier we could never imagine that Microsoft would one day support Linux so seamlessly. But today, because of the competition, because to be in the race, right, they have to probably adopt to this model, right? Google Cloud, probably Google is a pioneer in many areas, right? I would always say that probably Google does what Google is doing today, probably the industry would adopt probably after a decade. So that is the kind of vision Google has. So these Google is a visionary company, I would say, right? So for your information, HCL is on Microsoft Azure. Yeah, so we have adopted Azure Cloud for our platform services. Okay, so this is a brief about the cloud computing. What is cloud computing all about, and the top cloud service providers. Apart from these three, there are many other service providers. Probably like you have the Oracle OCI, the Oracle Cloud Infrastructure, you have Tencent Cloud, you have IBM Cloud, you have SUSE, DigitalOcean, right, Rackspace, and so on. So, but these three are probably having a lot of market share. Probably 70, close to 75% of the market share is owned by these three. Yeah, and they are probably leveraged across many enterprises. Let's move on to what are the different cloud computing models we have, right? We need to understand how this cloud computing is divided into. So if you look at this cloud computing, it typically are multiple types. You have the public cloud, you have the private cloud, you have something called the hybrid model or the hybrid cloud, and then we have one more model which is probably gaining up a lot, which is multi-cloud, right? So as all of us know, what is a public cloud? Anybody can probably go and create an account in AWS or Azure or GCP, and probably they can start. It is probably like, to put it in simple parlance, right? Let's say I'm part of a gated community, right? Where I have, let's say, a lot of flats in a society, and probably I am being one of the residents. So similarly, public cloud, anybody can probably create an account, set it up, and then probably they can start leveraging all the services of that particular cloud service provider. So that is where we talk about AWS public cloud, GCP public cloud, Azure public cloud, yeah, which is open to everybody. Then we have this private cloud, which is where we typically talk about managing your private data centers, right? So a private cloud can be physically located at your organization, right, on site or on-prem data centers, right? Probably why we need a private cloud. A private cloud is mandated by regulation, because let's say if I am an insurance company or if I am a financial institution like a bank, probably I cannot offer everything on a public cloud, because I cannot expose everything on a public cloud, because a public cloud is something, when you compare this to a private cloud, is insecure, right? You don't have too many security features. So that is where organizations would need some kind of security. So in that case, probably what they would do is they would go for a private cloud model, where they can probably have their own virtual private cloud setup as part of, let's say, AWS, right? So we have something called AWS VPC or the Azure virtual private cloud. I have my own dedicated network, the virtual private networks. I can have my private gateways, I can have my public gateways, right? And so on. So this gives me a lot of security. But when you compare the cost model, right, obviously why we are migrating to cloud is probably I'm moving from a capex model to an opex model, where I don't want to invest everything as part of my capital expenditure. I would like rather focus on the operational expenditure, where I would pay for what I leverage or what I use, right? Pay as you go, right? So that is what is the adage of this cloud adoption, right? So where I would primarily look at how would I reduce my cost. Private cloud, since it brings in more security, it brings in more features, probably in terms of cost, it is expensive than public cloud. Public cloud is probably the cheapest. So for example, let's say I want to explore or I want to learn AWS. I want to explore all the services of AWS. What I would do, AWS gives you something called a 12 months subscription, where you can leverage, let's say, a T2.micro instance, or you have a set of services which you can explore free of cost, within subject to a certain restriction, right, for 12 months without paying a penny. So that is where public clouds are cheaper. So when you are trying to learn something, when you're trying to probably experience what is cloud all about, you can probably go with all these AWS, Azure, or GCP. Right? A private cloud is something which organizations would look into, right, to ensure that the data is secure, the services are secure. And then we have this hybrid model, which is a combination of public plus private. So what is this public? As I said, a public is something where every service can be accessible, but in terms of security, it is weak. A private cloud probably where you have you have a lot of restrictions in terms of security. Only it is accessible to the ones who are supposed to be authenticated and authorized, not everyone, right? A hybrid model provides that kind of a cushion where organizations would like to look, so where they want to probably do this cost optimization. So all sensitive services would be part of private cloud. All non-sensitive services, or probably the services like, let's say, some kind of uh, a kind of a, let's say, a data mining kind of a stuff where I would like to probably generate certain reports. So these are something which is not core, right? So these are all probably your add-ons, right, for analytics. So these kind of services probably can be leveraged using public cloud, and then certain services can be leveraged using private cloud. So let's say, for example, an MNC bank, right? So where they could probably go on with a private cloud for their core banking, retail banking, and so on, right? But for example, reports, let's say some kind of backups, probably they would look at probably managing them using public cloud. So this is where we typically talk about how would you use this hybrid model. And then, as I mentioned earlier, we have this multi-cloud solutions, which typically talks about having two cloud providers or two cloud service providers, let's say AWS and Azure. Because why organizations would like to go with that? They want to avoid something called a vendor lock-in. What is vendor lock-in? I don't want to lock my applications or my basket of applications with a single vendor like AWS. For example, organizations or enterprises are probably skeptical about downtime, right? If there is an outage, right, what would happen? So probably my applications would be down, right? So that is where, to mitigate those kind of scenarios, they would probably go with multiple cloud service providers. So let's say 50% of the applications would be managed using AWS, 50% of the applications probably would be managed using, let's say, GCP or Azure. So that is where they would be able to avoid this vendor lock-in. They would be able to probably mitigate those downtime scenarios, right? So wherein they would probably look at the resilience of their applications also. So this is where today multi-cloud solutioning or multi-cloud probably is also gaining a lot of popularity. Yep. So with this probably, so these are the computing types or the deployment models, the cloud deployment models: public cloud, private cloud, hybrid cloud, and you have the multi-cloud. Uh, Next slide, please. Yeah. Okay, so now we have seen what is cloud computing all about, why cloud, right? What are the different deployment models? Let's look at the most important thing, the cloud service models. So this is where probably the crux of your cloud services they like. Whatever services you are looking at today, right? So they fall under these broad umbrella, which is infrastructure as a service, which is otherwise known as IaaS, platform as a service, which is very popular. Platform as a service is otherwise known as the PaaS, PaaS, and then we have SaaS, software as a service. And apart from this, you have this on-premises, which is typically a private cloud, right? If you look at the set of components, right, which are part of these services. So let's look at the on-prem quickly. So you have the storage services, you have the networking services, you have the compute services, you have the virtual machines, operating system, runtime, application, data, and access. So that is your application, the front-end application or the UI, right? So all these, the ones which are depicted in green, that is managed by the team or the organization, right? The cloud service provider doesn't come into picture. So this was the case when typically before the cloud, we used to have this on premises or at our data centers, right? Today we are talking about infrastructure service. So you could see this where the storage, networking, compute, which is depicted in sky blue, right, which is managed by the cloud provider or the cloud service provider. I would use the term CSP, cloud service provider. And the rest, you could probably choose a virtual machine based on your demand. Let's say it could be a 2 CPU 16 gig machine, right? Or it could be, let's say, 8 gig machine or 4 gig machine. It depends on what is your requirement. What kind of operating system would you like to go with, whether Windows based or Linux based, right? What would be the runtime, right? Whether you want to probably go with a JVM or a Node or let's say any other runtime, and then applications and your data and access. So this is where the ones depicted in greens are managed by the organization or the project, the ones which are highlighted in sky blue is managed by the cloud service provider. So this is what is known as infrastructure as a service model. So where instead of probably having a bare metal, probably I can just go with this, where the core is provided by the cloud service provider and rest I can manage. So this gives you a better control. So this is adopted when probably I'm talking about only spinning of virtual machines, right? Or a virtual machine scale sets where I would have a cluster of nodes, right? So that is where infrastructure as service typically talks about provisioning infrastructure in terms of storage, networking, compute power, right? When we talk about platform as a service, here you could see till runtime, it's managed by your cloud service provider. And what is managed by the team or the project team is the application. So this model has gained a lot of traction today. It is very popular today among the enterprises. So the classic example is if you probably come from a DevOps or a platform background, probably you must be aware of OpenShift, Red Hat OpenShift, right? Which typically is a very, very popular implementation or a distribution of Kubernetes, right? So which typically allows you to just focus on the application functionality rather than probably looking at the underlying components. Rest everything is managed by the cloud provider, only the application is managed by the teams. So this is where platform as a service probably brings in a lot of advantages to a team where they need not worry about the underlying infrastructure, underlying operating system, underlying runtime. So that is something which is covered by the provider or the vendor, who probably would say, I would give you a 24/7 access to all my support services. You just focus on building your applications. But in terms of cost, obviously it is going to be expensive than infrastructure as a service model. And the last one, probably all of us are familiar with, right? So where we talk about software as a service, where we typically talk about using that particular service, right? Or the software or a solution. For example, your Gmail services or Dropbox, or you talk about, let's say, Outlook 365, where everything is probably managed by the cloud service provider or the vendor, and probably I just configure with my, let's say, basic credentials or certain set of configuration information, and then I'm all done, right? So these are the most important cloud platform service models which we talk about. Yep. So you have your on-prem, which is private cloud. You have infrastructure service, platform as a service, software as a service. Apart from that, today we have many other service models on cloud. For example, you talk about DBaaS, database as a service, function as a service. Today we are moving towards an architecture which is more towards a serverless architecture, a event-driven architecture, a cloud-native architecture. So we are talking about something which is offered as a service, right? Which is known as function as a service. Those who probably are part of, or those who know what is this microservices architecture all about, probably you can look at what is the serverless architecture, which is gaining a lot of traction, which is typically known as event-driven computing, right? So this is how we typically look at this cloud platform service models. And on the right hand of this slide, you could see how this is getting deployed, right? You have the deployment models, which typically, as I mentioned earlier, public cloud, multi-cloud, private cloud, or hybrid cloud. Then you talk about your infrastructure service, which is probably the first layer. And then you have the PaaS, you have the SaaS, and then you have your clients, who could be a web browser, a mobile application, a thin client, a IoT device, or a blockchain device, or any kind of device through which I would be able to access my application. So this is typically what is the core of cloud. Next slide, please. Okay, now we have got a fair idea about the deployment models. We have got a fair idea about what are these platform service models. Let's look at what is the journey to cloud, right? So now let's say I am an organization or an enterprise which is still on-prem. Let's say still I am onto my legacy, which is a monolithic application, right? I would talk about monolithic application and microservices in a while. So let's say if I want to probably begin my journey towards cloud adoption. So there are multiple ways I can do. The most important one is probably how would you migrate your existing services and applications, right? So we have something called the lift and shift model, where I can just lift my application and probably I would migrate onto a cloud service provider, right? But I may not leverage all the services of the cloud provider, right? So that is where I'm typically looking at lift and shift model of migration or migrate. What is this modernize? Modernize is when you are probably looking at using or leveraging all the CSP's services, right? So we talk about the cloud native applications, right? How would you design? See, there are multiple ways I can probably leverage cloud. One is a plain lift and shift. That is one. What I can do is I can probably refactor my application in terms of design, in terms of architecture, in terms of technology implementation. I can refactor it, right? So that is which is known as redesign or refactor. So that is one way to probably migrate my services or applications to the cloud, right? The other one is I can design something called using cloud native features. Now, this is what is the topic for today's discussion. How would I modernize my application using this cloud native? So let's look at that. Yep. Next slide. Okay. Now comes the core of our discussion, which is cloud native. What is this cloud native and how it is different from cloud enabled? These are two very important terms which we need to understand. Cloud native, before we discuss cloud native, let's discuss cloud enabled. What are these cloud enabled applications? These are developed using a normal traditional software methodology or a normal SDLC, but can deploy in the cloud without taking full advantage of the cloud. So this is what is known as cloud enabled applications. As I said, I've talked about migrating from my on-prem to cloud, lift and shift, right? So that is something which is known as cloud enabled. If I'm refactoring my application without probably using all the services of cloud, that also probably would be part of cloud enabled. Now, what is this cloud native? Cloud native talks about implementing architecture or choosing architecture and technologies, right, which are probably an approach towards designing, building, and operating workloads that are built in the cloud, taking full advantage of the cloud computing model, right? So we will see in detail what are these architecture and technologies all about, right? What we are talking about in terms of design, in terms of construction, in terms about operations or ops, right? So cloud native was popularized by an organization or a foundation which is known as Cloud Native Computing Foundation. Shortly, it's known as CNCF. And probably those who are familiar with DevOps or Ops, probably you must be knowing CNCF, right? So Kubernetes, or you talk about any other very popular tools and technologies, they are part and parcel of the CNCF. So the Cloud Native Computing Foundation, it has an official definition which says what are these cloud native technologies and why it is so important, right? Cloud native technologies empower organizations to build and run scalable applications in modern, dynamic environments such as public, private, and hybrid clouds. What are the technologies? Containers, service mesh, microservices architecture, immutable infrastructure, which is again gaining a lot of popularity, infrastructure as code, which is known as immutable infrastructure, and declarative APIs exemplify this approach. These techniques enable loosely coupled systems that are resilient, manageable, and observable, combined with robust automation. They allow engineers to make high impact changes frequently and predictably with minimum toil or minimal toil. So, this is what is the official definition of cloud native, right? Which was popularized by Cloud Native Computing Foundation. To give you a brief about the CNCF, Cloud Native Computing Foundation, it is a consortium of 300 companies or organizations, which includes Google, which includes Facebook, Amazon, Netflix, and so on, right? So these guys are the members. In fact, Google was the one, right, who has the company, as they have committed almost $300 million towards CNCF activities. And today, a lot of tools, when we talk about cloud native, are part and parcel of this foundation, which is known as CNCF. So today you talk about containers, you talk about service mesh, you talk about APIs, you talk about the protocols, you talk about observability, monitoring. Almost all the tools are part of the CNCF, right? So that is where Cloud Native Computing Foundation is a core towards adopting cloud native solutions. I hope all of you are clear with this definition, which is cloud native. So cloud native typically talks about how would you design, construct, operate workloads, right, on cloud, right, with right architecture, with right set of tools and technologies. Okay. So if you look at this cloud native maturity, so probably this is very important, right? Where we talk about the three different waves. We have the wave one, the wave two, and the wave three. So when we talk about wave one, this is typically the cloud enablement, which I talked about, where we talked about the lift and shift model or the migration. We talked about refactoring, right? So this is where wave one. So today, many organizations have moved from cloud enablement to cloud optimization, which is otherwise known as cloud native transformation, right? So where we typically talk about how would you leverage the architecture, the tools, the technologies, right, to adopt something called cloud optimization and cloud native, right? So where predominantly we focus on DevSecOps, scalability, right, containerization, agile, API first policy, event driven digital decoupling, right, and microservices architecture. Right? So this is where we are today. We are probably moving towards. So from wave one, right now we are focusing on wave two, and the next set of transformation or optimization or innovation and culture probably is talked about in wave three, which typically talks about the zero trust architecture, which talks about your cloud native IDIs, blockchain, AI driven development, machine learning, NLP, 5G, quantum computing, and so on. Right. So this is wave three, which probably would take some time for the organization to mature into. Today, we are looking at wave two, which is where organizations are focusing on building cloud native solutions. So this is what is a typical cloud native maturity model, which typically shows what is going to be our journey towards adopting cloud native to its fullest. Yeah. Next slide. Okay. So next slide. Yeah. Next slide. Okay. So when we talk about the cloud native definition, we talked about two important things, right? One is the architecture. So this is a typical traditional monolithic architecture or design where we have everything clubbed in a single server. You have your client, you have your it is typically a client server architecture where we have everything, like you have the database, you have the server processes, you have your client, all probably in a single server or a single box, right? So this is what is a traditional monolithic design, which was earlier adopted, which was easy to build, easy to test, right? It was simple to deploy, simple to scale horizontally by running multiple copies behind a load balancer. But today, if you look at the way enterprises or the digital transformation has evolved, today we are talking about distributed systems, and distributed systems are probably highly complex, right? So for example, an organization like Amazon, which has a disparate systems, probably they have so many systems interfacing with each other, right? And it is kind of a mesh which is typically so complex in nature. So they could not adopt, or they cannot go with something like a traditional monolithic design. They have to look at something else, right? So let's look at what is that actually. Next slide, please. We talk about the cloud native design. We talked about the architecture. So if you look at this architecture, probably all of you could make out this is something known as the microservices architecture. So this is part of the definition where we talked about cloud native involves your architectural implementation. So when you want to probably start designing something, what is the architecture which you're going to adopt? I'm going to adopt a microservices architecture where applications would be decomposed into small isolated microservices. Each service, for example, you have many services listed here: the identity microservice, catalog, ordering, basket, marketing, locations. Each service is self contained with its own code, data, and dependencies. Right? So, when you talk about a microservice typically would have three components: the UI, the backend, and the database. So, they are typically known as polyolithic and polyglot, right? So these are some terminologies. So a polyglot typically talks about, you can, for each of these microservices, you can probably have your own data store. It could be a relational database like MySQL, or a Postgres, or an Oracle database, or a NoSQL database like Cassandra or MongoDB or Redis, right? So each service would be deployed as containers managed via a container orchestrator. So that is where we are looking at Docker and Kubernetes, right? The next one is the databases, which could be relational and NoSQL, how they would communicate with each other, how a microservice would communicate with other microservice. So that is where we talk about the RESTful APIs, which could be probably your gRPC protocols or NAT protocols ones, right? It typically talks about the event streaming and message brokers like Kafka, right? So that is how they would typically would be consuming or publishing and subscribing pub-sub model, which we talk about. We talk about the communication, the synchronous and asynchronous communication, right? So that is how they would be able to communicate. API gateway service is responsible for directing traffic to the core backend services and enforcing many cross-cutting concerns, right? Leverage scalability, availability, resiliency features of modern cloud platforms. So when we talk about the architecture, typically we talk about the microservices architecture, which is the core of cloud native design. Yeah. Next one. To give you a quick introduction on this cloud native tools and technologies. So this is the second part of it. If you look at the definition, we talked about the cloud native architecture and technologies, right? So we have talked about the architecture in brief, which was typically a microservices architecture. And what is this microservices architecture? You could have probably seen in that slide. And now we are talking about the cloud native tools and technologies. What are these? So first one, probably the first part typically talks about how would you probably adopt a microservices approach in terms of architecture. The second one typically talks about how would you deploy your workloads. That is where we talk about containerization, right? How would you probably create containers to build, let's say, a UI, a backend, or a database, right? So that is where we typically talk about containers. We talk about Docker as a container runtime. The third one typically talks about a very important aspect, which is known as immutable infrastructure or infrastructure as code, wherein we talk about tools like Ansible, Terraform, Chef, Puppet, right, or Salt, right? So these are some very popular tools which are probably adopted for infrastructure as code automation, right? The fourth one, right, which talks about a very important area, which is known as orchestration. So whatever container workloads we are going to build, how we are going to orchestrate them in real time or in real world. So that is where we talk about container orchestrator like Kubernetes, right? So which typically talks about some important feature of container orchestration, right? Be it your scheduling, affinity, anti-affinity, health monitoring, scaling, failover, networking, service discovery, rolling upgrades. So these are the features of your container orchestration. So today we are talking about Kubernetes, we are talking about OpenShift, we are talking about EKS, AKS, GKE, Google Kubernetes Engine. These are some very popular container orchestration tools which are available on these cloud service providers. For example, I talked about AKS, Azure Kubernetes Services, which is available on Microsoft Azure, Elastic Kubernetes Services available on AWS, Google Kubernetes Engine, which is available on GCP, right? So these are the container orchestrator platforms on which all these cloud native containers, right, they probably would be orchestrated or deployed. Then comes the bottom slide, where you typically look at the bottom three pictures, which typically talks about a very popular technology, which is known as service mesh. A service mesh typically is a kind of a proxy, a service proxy layer, which typically aids the application container or the application layer or the data layer, which we talk about, right? So without getting into the details of it, so this service mesh typically acts as a sidecar, which is typically a helper layer, which manages the service to service communication for in a microservices implementation. For example, if I have only 10 microservices or 10 applications decomposed into 10 microservices, probably the service to service communication probably is easily identifiable, trackable, right? What if I have hundreds of microservices playing with each other? It is very difficult for anyone to probably manually manage it. So you leave it to a tool or a technology which is known as service mesh, which probably is added as a sidecar or as a helper container to probably ensure that that service to service tracking is managed and monitored properly. So that is where we typically talk about service mesh, right? And then we have this most important thing, which is backing services. So when we talk about backing services, any microservices implementation, so you have to have microservices architectural approach or design. Once you have designed, how would you probably build the workloads? You would use container based workloads. Once you build the container based workloads, you need to ensure that they are properly orchestrated. For that, you would use Kubernetes, right? If I want to probably uh, implement something called auto scaling, or if I want to automate my process in terms of how would you dynamically spin up instances or virtual machines on the fly, you would probably look at something called infrastructure as code, where you typically look at Terraform, or you look at your ARM, or you look at Ansible, Chef for infrastructure as code automation, right? So that is where you typically look at that. And then to monitor these services, the microservices, you probably would implement a service mesh. And then the backing services would be something like your databases, relational databases, NoSQL databases, streaming services, storage services, your monitoring services, right? Your security services, your distributed caching services, your analytics, right? Your message brokers. So these are all the backing services which any standard application should have. So these backing services are all available as part of the cloud service provider's basket of services, and these can be leveraged. So that is where now probably after this you would have understood what is this cloud native and what architecture pattern we have to follow. So today I have just discussed about the cloud native architecture using microservices architectural pattern. Apart from that, we have serverless architecture, we have the event driven architecture, we have the cloud native architecture also, right? So again, we are evolving into that, right? So still it is not matured. What is matured is the microservices architecture, which we are discussing today, right? And these are very popular tools which are probably popularized after the adoption of cloud native solutions. So to build a cloud native solution, you need to have a microservices architecture and this tools and technologies which I have just discussed about. So which you see in the slide is very critical. So that is where today you see there is a huge adoption, or there is a huge demand for people with knowledge on Docker, Kubernetes, DevOps, DevSecOps, site reliability engineering, monitoring solutions, and so on, right? Apart from those who are probably developers, even probably for you guys, definitely knowledge on Docker, Kubernetes would help, right? Next slide, please. And the thumb rule, right? So what are the thumb rule? So if you want to build a cloud native solution, right, you need to follow these 12 factor app methodology, which is a must, right? So this 12 factor app methodology helps you to probably build a cloud native solutions approach, right? If I want to build a cloud native solutions approach, I need to probably go through all these 12 points, like for example, what is this code base, right? Dependencies, how would you manage your configurations, how would you manage your backing services, how would you ensure that you have different environments like a development environment, a test environment, a production environment, right? And they all should be probably they should always be similar in terms of the parity, right? How would you build, release, and run? That is where you talk about your CI/CD. You talk about processes. How would you build your applications, whether they are going to be stateless applications or stateful applications? How would you probably ensure that your ports are, how would you expose your services via port binding, right? So you have your container ports, you have your host port. How would you probably expose your services? How would you probably scale out, right? How would you probably look at horizontal scaling or vertical scaling? Predominantly, we talk about, when we talk about concurrency, we typically talk about horizontal scaling. So disposability, right? So today, when you are talking about infrastructure, these are known as immutable infrastructure. There is a theory called the pet and cattle theory, where today the infrastructure is treated as a cattle and not anymore as pets. Right? Earlier we used to name the servers, but today, looking at the kind of dynamic environment we are in, right, we are supposed to probably spin an instance, finish our job, and probably terminate it. So there is no affinity towards a particular instance, right? So that's why these are known as cattle, right? So that is what is known as disposability principle. The dev prod parity, whatever I do on my development environment, right? Always my dev should be in on par with my prod environment, so that I would be able to quickly achieve my tasks, logs, admin process, or backing services, right? So these are the 12 factor app methodology, which is a must to build a cloud native solution, right? So with this, I would wind up my discussion. I hope all of you got some insight into what is this cloud native architecture, what are these cloud native tools and technologies, and what is this 12 factor app methodology, which is a must for building cloud native solutions. Yep. Kirlu, I'm done.
Thank you so much, Senthil, for such an insightful talk. We shall now begin the question and answer session. Kirilu, let's have the questions, please. Okay, our first question is from Navam, and he says that can I know a bit more about immutable infrastructure and relevance to Sri Lanka IT industry?
Okay, so I guess I would talk about immutable infrastructure, and it is not only for Sri Lankan IT industry; it is for everybody, right? So it is not only for the IT industry. It is basically it is one of the architectural principles. So today, when we talk about immutable infrastructure, as I said, the cattle versus pet theory, right? So where we typically don't name servers anymore, right? So when I talk about, let's say, uh, um, immutable infrastructure is something where once I create an infrastructure, right, I'm not supposed to update it. So that is where it is known as immutable. I should not be able to modify an existing infrastructure. If I want to modify something, I need to create a new one. Right. So that is where we typically talk about immutable infrastructure. So that is where today, if you look at tools like Terraform, if you have heard about Terraform, which is a very popular infrastructure orchestration tool towards automation, wherein you set up, let's say, an application, let's say if it is live, for example, an e-commerce, and let's say there is a peak load, right? What happens? This immutable infrastructure concept or the tools which we use would enable you to probably spin up instances or virtual machines based on the application traffic in terms of the CPU load, right? And based on that, it can scale up to, let's say, n number of instances. And once the traffic again peaks down, right, then automatically these instances would be shut down and terminated, right? So that is where organizations are saving a lot of cost actually. So this is what is the concept of infrastructure orchestration or infra automation, wherein we treat all these infrastructure as cattle and not pets, right? And immutable is something which is more towards I would not be able to modify anything. These are like you provision them, use them, probably terminate them or kill them. That's it. Yeah. So that is what is immutable infrastructure all about. And it is not only for the Sri Lankan IT industry, right? It is for everybody in this world who is probably looking at adopting cloud native solutions, right? So this is across any enterprise, be it in Sri Lanka, be it in India, or be it in US, right? It is applicable. Yeah.
Thanks, Senthil. Kirilu.
Yeah.
Dimanta asks us, how do you see the evaluation of security with the popularized cloud native services models?
Okay. That's a good question. As I mentioned earlier, when we talk about the cloud native optimization or cloud native transformation which we are talking about, right? So where we are talking about the wave 2, you would have seen one of the most important thing is DevSecOps, where security is part of your implementation. Today, without security, probably your entire CI/CD implementation, when we talk about continuous integration, continuous deployment, right, it is incomplete, right? So security is no more an option today; it is a must. That's why when we talk about security, we are talking about shift left model, which typically talks about two important things. One is the shift left security, the other one is the shift left testing, right? So as soon as you begin your development or design, you start parallelly building your test cases. So that is where we typically talk about test driven development. You probably talk about your security tools, a pre-commit, post-commit set of tools, right? Which typically allows you to probably ensure that you don't leak any kind of security vulnerabilities, or you don't have any kind of security hotspots. So security is something which is a vital, which is a must, and it must be part of your implementation. So that is where you need to adopt this shift left model. Yep.
Thank you, Senthil. Kirilu. And Krishanti asks, how important is API first policy in cloud native optimization?
Yeah. API first policy is, so today APIs probably can be built, can be sold. For example, a classic example in India where it was very popular today, right? the way we had built our COVID portal, right? And today, the kind of the portal which you look at, how hospitals are able to integrate that actually, because these APIs or the application programming interface logic, the business logic, right? It is probably provided or exposed by our government itself, where it says that you can just leverage your APIs and probably connect to your systems and then start leveraging it. For example, API first policy is something where you typically talk about, let's say, hotels tied up with so many vendors like Easy Trip or probably Clear Trip and so on. How these guys are able to show you the right status across any hotel in the world, because the organization would have exposed the APIs, and these guys are just connecting to those APIs along with their systems, and they are able to probably bring in the updated status of that hotel booking, right? So this is where API first policy is very important in terms of how would you expose your services, right, outside your organization, right? And this is something which is a must, because today we are talking about distributed systems, and without exposing my APIs, I will not be able to provide services or provision services to external world, right? So that is where API first policy is very important. Yeah.
Okay. Our next question is from M. Pereira. What are the key measures taken in deciding the tools and technologies in cloud native transformation?
What are the key measures taken in deciding? Okay, so when we talk about the tools, as I said, when you talk about a cloud native transformation, especially you're talking about you're adopting a microservices approach in terms of architectural design. When it comes to tooling, you talk about containers, container orchestrators, service mesh, your SQL databases, NoSQL databases, your event streams, your message brokers. You talk about monitoring solutions. You talk about your distributed caching devices or tools for CDNs, right? So these are the tools which typically we talk about. Apart from that, you have the infrastructure as code tools, right? Where I mentioned about Chef, Puppet, Ansible, etc., Terraform. So these are the tools. When you talk about the measures, I don't know whether you're talking about the metrics or you're talking about just how would you transform or what tools you would use to probably bring in this cloud native transformation. If I'm talking about the metrics, probably you're talking about the shorter lead times, right? You talk about MTTR, the mean time to remediate, the mean time to detect, deployment frequency, right? So these are some measures or metrics which you typically would measure, and this is common across whether it is going to be on cloud or using cloud native solutions, or whether it is going to be on prem. These metrics are going to be the same. Yep. What are the key emerging skills an IT professional in cloud native services should capitalize on? Yeah. So the key emerging skills, as I mentioned, right? It is going to be probably for an IT professional, right? So when we talk about a full stack developer, right? Apart from your primary skills, let's say if you're a Java full stack, right? Understanding of DevOps, understanding of Agile, right? Probably a bit of scripting is a must today, right? Probably let's say if I'm let's say a UI developer, right? So today I cannot say that I'm a full stack unless I know a bit of a backend like Java, a Java Spring Boot, right? I cannot I cannot be aloof with Agile. I have to learn Agile, because today every project implementation is probably adopting Agile, Scrum or Kanban or whatever it is. DevOps is something which is a must, right? So you need to learn Docker, you need to learn Kubernetes, you need to have a bit of exposure on scripting, be it Python or Go or Linux scripting, apart from your primary skills. So that is how you would probably qualify to be a full-fledged, a full-stack developer. So please build your skills on these areas, right? Which is a must, yeah. And today, site reliability engineering again is catching up, which is again something which extensively is towards ops, right? How would you probably bring in your reliability and stability in operations world, right? So that is where we are probably, even developers need to have that kind of an orientation if you want to become a site reliability engineer, right? So these are some important skills which we need to probably nurture upon. Yeah.
Thank you, Senthil. Uh, Unfortunately, we have had only this much time for the questions today. If you have any more questions, you can post it in the comments section for the platform you're on, and we will get back to you later. Thank you, Senthil, for such an insightful session today. Cloud native services are definitely here to stay. It's a wonderful and very exciting field. And next time, every time you look at your mobile app and you're looking at Netflix or Facebook or something, you can really realize what's the exciting technology which is behind it. Thank you for your questions as well. Thank you, everyone, for your valuable time and presence. Please note that the recording of this live session will be available on the HCL Sri Lanka YouTube and Facebook channels. With that, we conclude this Tech Biz Talk. Thank you once again for joining us. Stay safe and take care. Bohoma Istuti.
Thank you all. Thank you. Bye.